For decades, physics dictated a strict compromise in automotive engineering. If you wanted extreme speed, you stripped out everything else. You lost the radio, the soundproofing, and the comfort, leaving only a raw, track-focused shell. Then, the chairman of Volkswagen Group, Ferdinand Piëch, decided to ignore that compromise. He issued a non-negotiable mandate: build a production car with 1,000 horsepower, make it exceed 400 kilometers per hour, and make it as comfortable as a daily driver. These targets actively fight each other. Top speed demands minimal weight, luxury requires heavy materials, and immense horsepower creates thermal loads requiring massive cooling systems. To the engineering team, these metrics weren't just ambitious, they were mutually exclusive. By the standards of the time, building this car wasn't an engineering challenge, it was an invitation to failure. While V8 engines existed, they couldn't deliver 1,000 horsepower reliably while maintaining luxury refinement. Hitting that power mark required a total departure from traditional engine architecture. The solution was an 8-liter, 16-cylinder engine block fed by 4 independent turbochargers. But power comes with a thermal cost. The engine produced so much destructive heat that if left uncontrolled, it would melt its own components from the inside out in minutes. This schematic illustrates the scale of the crisis. A standard car uses one primary radiator. Bugatti had to engineer a vascular network of 10 specialized cooling units just to handle the thermal load. The mechanics beneath the hood were no longer just about performance. They formed a complex life support system designed to stop the machine from destroying itself. As the car approaches 400 kilometers per hour, the air ceases to act like a gas and becomes a dense, physical wall of resistance. At that velocity, a millimeter of aerodynamic flaw can lift the entire chassis off the ground, causing a fatal crash. To keep the car grounded, Bugatti engineered active aerodynamics. In top speed mode, the car physically lowers itself toward the pavement and adjusts the rear wing to force the chassis into the road. Here we see the final crisis. 2 tons of luxury materials are crushed downward by aerodynamic force, while the sheer rotational speed tries to pull the rubber apart from the inside. Standard tires would literally explode under these forces. Bugatti had to halt development and engineer entirely custom, high-speed rated rubber just to survive the speed. It was a cascade of impossibilities. Every solution birthed a violent problem, hovering on the edge of destruction. After years of failures and redesigns, the engineering team in Molsheim, France, finally verified that the car could stabilize at over 400 kilometers per hour. It was a complete reality. A single machine housing 1,000 horsepower, record-breaking speed, and full luxury comfort. This chart reveals the financial reality. While retail prices were millions, actual production costs were astronomically higher. Bugatti lost millions per unit. Profit wasn't the point. This blank check experiment by the world's largest automaker proved what's possible without financial constraints. The Veyron remains a singular monument to what happens when a refusal to compromise meets endless resources. A machine that forced the most violent contradictions of physics into a single functional chassis.